Thank you, and good morning, everybody. I appreciate our live audience here. It's very nice in these times to have both a live and an online audience, and I appreciate everybody out there who's streaming our event this morning. My name is Basil Alwan. I'm CEO of Tarana Wireless, and a little introduction. I've actually been at Tarana here for about a year, but I started engaging with the company 3 years ago. And just prior to this, I was running the IP optical division at Nokia. I know many of you from those times where I spent a couple of decades building big routers in the core of the internet, and started my career actually in silicon at Advanced Micro Devices. So been in and out of technology for a long time. One of the things that was interesting about being at Nokia most recently, I was running a quite large division of the company, and I would hear a lot of stories. So I'd hear a lot of companies coming in and pitching what they're doing. I got to be pretty good at sussing out which ones are interesting, which ones are not. And so I want to start this morning here with a little bit of a story about Tarana. I'm going to tell this story with a few numbers, and this will become clear to you here in a minute. But I started my time with Tarana basically through an introduction from Greg Weiler, a satellite guru who got to know Tarana quite well. And he was amazed by Tarana's technology. And he called me up one day and said, "You got to meet these guys. These guys really have something." So the first thing that helped me here was Greg, a guy I know quite well. If he's saying this is something interesting, yeah, I'll take that meeting. I think I'll go ahead and find out what these guys are up to. So I met with Dale and Sergio and Rakesh and the team here at Tarana. And of course, they told me the story. And the story was, we have fixed wireless that actually works. And for those of you that have been in this industry for a while, that story's been told a lot of times. And there's a lot of skepticism around fixed wireless and what it can do and what it can't do. It's a tool, clearly. It's a product. There's quite a few products out there. But how far can fixed wireless really go? And the stories I was hearing from Dale and Sergio and the team were way beyond what I've ever heard in fixed wireless. So you can imagine what my first reaction was, skepticism. So a few meetings later, and deep into very deep technical explanations that go even beyond what I was able to comprehend at the time, I said, okay, well, this is interesting enough. Let's try this thing out. So the first two numbers on this slide are basically, I live in Los Gatos, up in the hills. So I'm part of the digital divide, on the not good side of it. The first two numbers are 7 meg DSL. That's the best DSL I can get up there. And it's on a 5 kilofoot loop, so that's the reason. And nobody wants to invest in fiber up there unless the government decides to help out. And there's no cable up there. So I'm pretty much stuck up there with a bandwidth issue. The second set of numbers is my last solution for broadband at my location up in Los Gatos in the hills. And the first number there is 25 megabits per second. That's the most bandwidth this particular piece of land has ever seen in the history of time. 25 megabits per second. Sometimes I would get up to 27, 28, and it'd be a big party. We'd have a lot of fun up there. But mostly I was at 20 to 25 megabits per second. Reasonably happy. Not great. The 99 is how much I paid per month, $99 a month for that service. Normally it's a $129 service, and I bought it from a local Wisp, very good company called Etheric, that provided a really great service and still does. So I figured, okay, if these guys are so great, and they tell such good stories, maybe I should have them up to my house, and let's see what they can do for my internet problem. And so the third set of numbers is what happened. They brought up, and the picture. So you can see the picture there is a picture of a tripod they brought up. At the time, Tarana was running a network out of San Jose, and the cell tower was quite far away, or the location of the base node. But the third numbers are 150 megabits per second, which is what I got when I turned on Tarana, which of course made me a believer instantly. In 40 megahertz of spectrum, at 14 kilometers. So this is non-line of sight technology. This particular link was line of sight. We're going to talk a lot about non and near line of sight. But I was getting this was in a half bandwidth prototype at the time. So this piece of land that had never seen more than 25 megabits per second now is sitting at 150 with a prospect of going much, much higher. And of course, the fourth set of numbers is what I'm using as my internet service, 24 by 365. And that happens to be Tarana at this point, of course, because it's a great product. And here I am. I have recently decided to, I actually invested in Tarana as a result of this, which is the first thing I did. The second thing I did was join the board and started working with the team quite extensively, and then in April I joined as CEO. So I'm a true believer. And the guys, when I was doing diligence on the company, said, hey, we get this a lot. We get a lot of these kind of comments of disbelief. People looking at this and saying, this can't be real. This is actually from quite a while ago. The company started by building maybe the Tesla Roadster of wireless. It was very expensive, but it always thrilled. And when people drove it, they were super impressed. This was from a company that was working on backhaul, which was the first product the company worked on. And they would use this as a kind of expensive but link of last resort. When nothing else could close, they would bring in Tarana, and this particular vendor was working with AT&T and helping them with their backhaul links. And this is the kind of stuff. And by the way, there are just quote after quote on our new website, which just went live. There's a bunch of really great quotes on there. Every customer who has touched this technology ultimately comes away going, how is this even possible? So in the words of a teenager, is this really a thing? I'm sure that's what you might be thinking. Is this really a thing? And if so, how is this possible from just a small startup? Well, this is a small startup that's been working for more than 10 years on this project. And a lot of sweat equity, a lot of time, and a lot of experience poured into this product. And of course, if you look at that last line, how is this possible from a small startup? You might think to yourself, well, that's kind of the story of Silicon Valley, isn't it? How is this possible from a small startup? Well, I'm going to tell you today how this is possible. And I'm going to do it, hopefully going to get you through what I call the 5 stages of belief instead of grief. So we're going to go through, I know everybody starts with denial. I did. I'm like, nah, can't be. Sergio, Dale, there's no way. You can't do this. And then the skepticism, like, well, maybe, but I just don't believe. How could that even work? Then a challenge. Hey, put that at my house. Show me that it works. Then optimism. I'm like, holy cow, this really works. And then finally, belief. And that was what I went through. I'm going to try to today get you guys through at least the first 4 stages of this. And I'm going to do the first 2, and our panel, I think, is going to help a lot with the challenge and optimism, since you won't be able to drive your own product. But this is for real. And fixed wireless, I would say, in the past, has been really more the 5 stages of grief, because it really does end up in acceptance. It's not a bad thing, but the reality is there's just so many trade-offs you have to make when you're using the traditional fixed wireless technologies. So let me start by saying what doesn't work for this problem, fixed wireless broadband. And the answer is, really the 2 major wireless technology locuses in the world, 3GPP and Wi-Fi. So if you're wanting to go non-line of sight, which is 80% of homes if you're sitting on a location, a cell tower or a water tower, whatever, if you're wanting to go non-line of sight, so you're stepping away from line of sight technologies, your choices are really these 2 options. And the challenge is that they're not built for this. They're not built for fixed wireless. The mobile system was, of course, built for a very different target, a mobile phone. And the tonnage is massively different. So in a fixed wireless environment, you'll do 50 times the bits, the tonnage that you will carry in a mobile network. And that has real serious implications on how the technology must be built. And Wi-Fi, of course, is extremely good and fast for homes and local areas. It's built for that. And you can use it. You can use it for point-to-point links. But it's pretty line of sight. It's very susceptible to interference. It's pretty low power because it's running in unlicensed spectrum. So these 2 technology systems, which most of the products in the world are built on top of, are just not good foundations for what we're trying to do in delivering broadband to homes and businesses. And that's why they haven't really gone mainstream. And when I say they haven't gone mainstream, that's not to say there haven't been successful products in fixed wireless, because there have been. Whether it's now 5G, which is in 4G and 5G fixed wireless installations, which are, available from a number of quite large and mid-sized companies, or whether it's fixed wireless access using traditional Wi-Fi technology kind of repurposed. But the challenge is kind of up here on this slide, which is basically you've got a bunch of tasks. If you want to deliver the tonnage that you need, and you want to deliver it in line of sight, not a non-line of sight, you've got a bunch of challenges here with these technologies. First, self-interference becomes a big limiter in terms of the number of homes or the number of targets you can put on a given sector. Multipath integration, meaning how do we take advantage of multipath and reflections in a non-line of sight situation. Doing that well is all about tonnage, getting the tonnage you need. Rapid adaptation is really super important here. And what I mean by adaptation is how quickly are you changing the parameters of the antennas to try to maximize throughput. And that, in the case of Tarana's technology, is radically different. And on and on. Asynchronous interference cancellation. And we'll talk a bit more about these as I go through the presentation. So the bottom line is, the only real choice here was to start from scratch. As it is in the Valley, you have to have some combination of experience and optimism in order to do something like this, because you embark on a journey that is undoubtedly going to be twists and turns. It's going to be tough, but if you're going to do this, the right way to do it is to start from scratch. Rethink everything. First principles, right? Not go back to grab a Wi-Fi chip or grab a 4G chip, but start at the beginning, and that's exactly what this team did. Reassess all the possibilities, because as Moore's Law evolves, as technology evolves, you can do more. And that's the story of the Valley is, every generation, something changes where you can do something that previously was not possible. Refactor all the algorithms. This is real tough stuff. This is deep math. This is how do you do the digital signal processing and how do you do the RF and the RF chain and all the pieces of this system to deliver something markedly different. Simulate. Iterate, repeat, a lot of invention, a lot of core invention here with algorithms, new algorithms that don't even exist in some of the other technologies. And then after you're done with all of that, you prototype it, you test it, you show it to some customers. In the case of the previous slide I showed, you have a product that's kind of expensive, but really proves out the technology. Then you have arrived at a point where you're allowed to say, let's build a product for fixed wireless. Because in order to hit fixed wireless, you have to build chips. And that's when the company embarked on building G1. It's been a heck of a journey, I would say, for the team. So what exactly did they get out of all this effort and all this time, other than a lot of time away from families and a serious amount of sweat? Well, first, a fundamental advance in reliable high-speed links without line of sight. This is fundamental. The challenge is that in most places, not all, but in most places, you'll have some obstructions. And those obstructions will cause reflections, refractions, and ultimately will cause a fading of the wireless signal at the cell edge. So line of sight's pretty simple. And most wireless engineers don't get that excited about a line of sight demonstration. You say, hey, here's my gigabit. And it's like, okay, well, not that exciting. What's really exciting is when you can show non-line of sight doing some really magical things, and it's hard. And in order to do this, what you ultimately have to do is you have to do the math to take all of those weak signals that are bouncing off of things and combine them in the digital domain, and then create a stronger signal from that set of weaker signals. It's a lot of calculations. It's a lot of math. There's more compute performance in these nodes than there is in any of the other wireless platforms for that very reason. You have to do some really complex things. But what we get out of this is we get the ability to operate with capacity where other systems will start to fail and completely fail, especially at the cell edge where there's a lot of interference and refraction. Another really innovative part of this, and then by the way, there's many more than I have time to cover this morning. Another really innovative part of this technology is that the ability to cancel interference. And not just self-interference, which is hugely important, because in cell systems that overlap, self-interference does become a huge limiter at the periphery, and you end up using a lot of your spectrum trying to deliver service to those cell edges. And if you're thinking about fixed wireless, where you have to have 50 times the bandwidth, if you're burning your spectrum, basically dealing with those cell edges, you don't have enough capacity for the rest of your subscribers, and it ends up being a real problem. This is one of the problems with fixed wireless fundamentally has been limiting. It's almost success breeds a limitation. Now, the more success you have, the less you can do because you can't continue to populate the systems. But the other magical thing here, which is well beyond anything that's out there right now, is canceling an unlicensed spectrum, canceling asynchronous interference. That is, not canceling your interference or interference that you're synchronous with, but asynchronous interference. Any interfere. And if you're going to operate an unlicensed spectrum, you almost have to do this because there's no other way to guarantee a service that's sufficient quality for a home internet service. So with COVID, with everybody running all their lives on these systems, it's no longer adequate to say, yeah, it works most of the time. It's got to work all the time. A byproduct, but really not only a byproduct, but a fundamental design intent of doing interference cancellation, both self-interference and asynchronous interference cancellation, is opening up unlicensed spectrum. And this is hugely important as well, because spectrum is expensive. It's geographically different, but it's very expensive. And you don't want to burn all your spectrum necessarily that you purchased on fixed wireless subscribers, because there's a 50-1 ratio for mobile subscribers. So the mobile bits you deliver are much more profitable. So in order to do this, we also leverage unlicensed spectrum. 5 gigahertz today, but also there's a massive swath of spectrum becoming available here in the US in 6 gigahertz that this technology is going to really sing in. So these frequencies have great propagation characteristics, but they're nearly unusable if you don't have this interference cancellation. So this is a very big deal, the fact that our products run both in licensed and unlicensed. So G1 is our system that we're talking about today, and this event is really talking about commercial availability of G1, because G1 is now not only shipping, but it's installed in a quite wide variety of customers, many of which are here today. We're really thankful for that. But G1, to start off with, what is G1? It's a platform. It's a combination of, it's an end-to-end system with a combination of a base node that sits on a cell tower or sits on all-inclusive, device. There's no baseband at the hut. It's all built into one, power in, Ethernet out. And that sits on a cell tower or a water tower or some location, high location, facing the customers that you want to serve. And then there's a remote node, a small little remote node, which we have here, and that device sits on a home. And one of the nice things about this system is it doesn't have to be perfectly aimed, because there's beamformers on both sides. And there's a completely symmetric system here in terms of capacity and capability. So we deliver with that really fiber-class service. And this is kind of the thing that got intrigued me, was that for the first time, we're getting hundreds of megabits per second per customer. And now we're talking about a service that can go the distance for customers. 2 and 2.4 gig shared per sector. 9.6 gig per tower if you just do 4 sectors. Obviously, you can stack these, so you can do more than that, and I'll talk about that a bit later. One of the really key things here is flexible uplink-downlink ratios. So with this technology, since it's symmetric, it's retro-directive, as Dale would say. That means that if you use some bandwidth with the uplink, it's exactly the same as downlink. In traditional systems, the more you use in the uplink, you burn a lot more capacity, spectrum. In this system, it's kind of a trade-off. You just decide. We have a 4.5-to-1 ratio downlink to uplink, but if you want a 1-to-1 downlink to uplink, that's just a decision and a feature that we can offer. No penalty. Long range, 3 to 5 kilometers, 10 kilometers line of sight plus. K equals 1, another fundamental thing here, which allows us to operate in one swath of spectrum around the tower. You don't have to go, 1, 2, 1, 2. You can actually use spectrum much more efficiently this way. And that comes from the self-interference cancellation. So there's a huge amount of stuff here, but the bottom line, and I want to jump to here next, is how real this is and where we are in deployment and shipping this product, because that's the magic, that's the real interesting thing for today. The last thing I'll say is this is all managed by a cloud suite, which is really nice. So it's fully managed end-to-end, so there's no complex installation of software and things like that. It comes up, you're on the system, you can see all the details of the wireless link, what's going on with your customer. It's all built into the system. So the next few slides, I really want to talk about how real this is now, which, of course, when I joined, one of the big issues was the chip wasn't done yet. And for those of you that have been around Silicon Valley startups, when that all-important chip to get the economics of the home device is killer. If for some reason it doesn't work, you don't have a product. And and nowadays, with silicon, having spent a decade in the silicon business, nowadays, unlike the old days, if you miss a spin of silicon, you're going to be spending a lot of time, possibly a year and a half, getting to your next generation. So a key part of this was getting that silicon right. And in the case of G1, actually, there's 3 custom chips that were built to kind of completely design, develop, redevelop what these systems can do. This is a great link because it shows that this is one of our sectors that's up and live right now in Joplin, Missouri. This happens to be with Wisper. It's in 5 gigahertz spectrum, so this is unlicensed spectrum using 80 megahertz. So it's using our RN over 2 carriers. You can see the 5.6 mile distance, and the middle number tends to surprise people. And it particularly surprises people if you look at the tree that remote node is going through right there. If that was a clear line of sight link, they might say, okay, I get that. Most people look at that and say, I don't get that. How is that even possible? And so it is possible because it's up and running and delivering service to a customer right now. And you can see the signal noise ratio and the kind of the characteristics. This is probably the more important part. And this is from a customer of Nathan's here at Wisper. And this is his quote. I've been trying to get Wisper to serve me for 2 years. They all said they couldn't. Now they can. And boy, can they. They can roll a service that he can, they can offer a 100 meg service, a 200 meg service. He can buy what he wants to buy. Huge, huge change. But G1 is real. The real, for me, when I joined, was, what I really wanted to see was not one link. I wanted to see a sector. I wanted to see a sector fully populated, or heavily populated with all of the links up and running. That, for a wireless engineer, that's always more important because, again, typically as you add links, you start to suffer all the issues with interference and fade. And what you find pretty soon is your capacity starts to really get under pressure. These are two sectors. One is in with Resound, one of our customers who are here today, and one is with Wisper. And you can see 101 RNs on one, 79 are remote nodes on another. Now what this is actually a graph of signal noise ratios. So what it's showing is all of these links. And the important thing, it's a bit of a geeky slide, so I apologize for those of you that are not deep into the engineering, but I'll try to make it a bit simple. The colors represent how non-line of sight, or how much path loss there is from what would have been a line of sight link. So where you can see there, if it's blue, it's a clean link. That means there's nothing in the way. It's just the distance is all that's creating the path loss. As it gets more and more green, yellow, and then red, those are pretty seriously obscured links. And this is measured. This is not a planning tool. This is measured from our own systems. So basically what we're showing is the path loss on each of these links. And you can see a little table down there that says what is possible with our modulations based on path loss. So what you can see is we can offer services across a pretty broad sector. Not everybody's going to take them. Somebody might want 25, somebody might want 100, some people might want 400. And our customers are actually offering 400 and 500 meg services now. And as you can see, on a link basis, a very high percentage of these links are capable of really, really high bandwidths. This is really the difference and the important part of what the technology that Dale, Sergio, and the team here have developed has created. Of course, what really matters here most is the technology is great, but how does it translate into business advantages? And this is a project we did, or a sector we looked at with Resound down in Texas. And in this particular case, we looked at, hey, if we wanted to offer 1,600 subscribers, a baseline service 100 by 20, meaning they could all actually have 100 by 20. How much gear would it take, and how many towers would it take, or locations, with our product and with an alternative in the market today? And you can see the difference is really, really remarkable. And this is real. When I say this is real, these ratios I'm showing you here are roughly correct. In other words, the technology is so powerful, it can deliver the same service with way fewer towers, right? And maintain the service level. And more importantly, perhaps, you can offer a higher performing service. So you can, for customers that do want to buy more than 100, or 200, or even 300, they can do that. So you can monetize more effectively. So the TCO is lower over a 5-year period of time because there's less towers, less backhaul, less infrastructure. It's more reliable, obviously, because there's less of those. Higher revenues per sub are available, therefore ability and the ability to scale to much higher penetration rates because of, again, back to this issue of capacity, tonnage. The bottom line is we enable a bigger, better business, which, of course, is what motivates our customers and motivates us ultimately to go after this. But the real game we're after here is not just serving rural customers or rural towns, although we very much want to do that, and we're going to have some panelists here in a minute that are going to really, I think, elucidate the wide variation of locations that we're starting to deploy in. But here's a real planning example we did in Sacramento of how would you offer a service across an entire metro area. In this case, all of the households in Sacramento. And there was a ton of work, and this is very detailed work because we went house by house on this. And we used a planning tool that's pretty sophisticated to look at what are the locations we would pick and how many locations would we need to offer coverage in all of Sacramento. Every house, you can have a service, flyer goes out, new internet service available. And it's 18 locations. That's for coverage. And then over time, as customers subscribe to the service and we have success, you can densify. And you can densify. In our study, we did I think about a 5-year study here. We ended up with 43 locations to get capacity, enough capacity to serve, a really meaningful percentage of the older subscribers, 24% market share. This is game changing. This is game changing. Now, this particular project, we also layered in the out years G2. And we're not going to talk about G2 today, but suffice it to say, it's going to be an amazing product that allows us to provide gigabit rates on a per-user basis in a very, very straightforward way, even non-line of sight. This is going to be another really big step for the industry of fixed wireless. What I'm trying to say here is that what we're announcing today and we're talking about is Tarana here is after endgame broadband. We're not here trying to build a stopgap to fiber. We're not trying to offer customers, hey, here's something you can do fast, and of course later on you're going to want to come back and backfill fiber. We're not building that. We're believers that wireless is a true alternative to fiber and is a long-term, durable alternative to fiber because the technology trends are in our favor at this point. Each successive turn of the crank on Moore's Law gives us even more capability to leverage the technology, the fundamental algorithmic technology that we built here, and will allow us to increase capacity and performance. So we're talking here about a service that can go in and stay in. It's not saying that fiber isn't great, it is. And fixing broadband globally is not one technology, it's a multiple technology. But this is a new thing. It's a new option to broadly use wireless for endgame broadband. So the opportunity we think is quite huge, and we're excited about our initial deployments. We have hundreds of base nodes now in production, in service, and we're ramping on remote nodes and households as we speak, so that we're really well into now deploying G1 in several continents. But our mission, of course, is bigger. Notwithstanding the recent news on the difficulties of some of the web-scale players, we remain convinced that the internet is good and is important for advancement of people, entertainment, productivity, and so the digital divide's real. And I think the team here actually started the company with the idea, actually, of solving the digital divide or helping to make a difference in the digital divide. And in fact, one of our panelists this morning is all about that, Calvin Collett. He's going to join us by video from South Africa. Unfortunately, he was planning to be here, but flights and things like that got in the way. So he'll be on video. But one of the first installations of our systems is in South Africa, and really a remarkable story about how we're offering service to people who haven't really had a home broadband service before that's real. We also have here Neil McRae joining us, Chief Network Architect of British Telecom, to kind of give you an idea of a Tier 1 player that's looking at how this technology can affect and help them solve the challenges they have in the UK. And Nathan Stooke, who's one of our customers that I would say has had longer experience with Tarana than even I have, is a technology evangelist, built Wisper from the ground up. And Nathan, please come on stage and join me now. We'll start the panel here.
Great. Do I get to pick one?
I think I'm going to sit with you here.
All right, very good.
Okay, there we go. We have our panelists here.
Perfect.
Good. Hey, Calvin. Hey, Neil.
Hi.
You guys hear me okay?
Basil, how are you?
Good to see you.
Good.
This is
Hi, Basil.
Hey, Neil, how you doing? This is panel in COVID time. This is what it looks like.
It's pretty impressive, actually.
I'm actually pretty impressed
Yeah.
that it's all working. Let's. I shouldn't have said that. That
Right.
might jinx it. Right?
At least it started working.
Yeah, exactly. Let me start off with you, Calvin, since I just gave you that quick introduction that I hope you heard. Some people were surprised to hear that South Africa was one of the first locations that Tarana ended up deploying in. One of the questions we get pretty often is, how do the economics work in a country like South Africa, and how serious are the governments down there about digital divide? It tells us a little bit about what's motivating MTN and Supersonic.
Yeah, thanks, Baz. I mean, I think it's one of the important things. The economics makes sense. Because it's wireless, one of our biggest assets is our towers. So we've got a massive tower network. Most of them are connected with fiber. So it's really about providing that last mile connectivity with a fiber-like solution that is not fiber, which will ultimately allow us to provide far better connectivity to the masses. Because that's one of the challenges we've got in South Africa, is that we've only got a very small percentage of the population covered with fiber, and the cost of actually rolling out fiber is prohibitive in a lot of the places. So it makes far more sense to actually do it wirelessly, and Tarana is a great product for that, and it's certainly showing us that it's a great product for that.
Appreciate it, Calvin. Maybe over to you, Neil. And a completely really different situation in the UK, where there's pretty good penetration of broadband. Maybe tell us a little bit about what's inspiring you to look seriously at Tarana and where it fits in your overall strategy for broadband.
Yeah, I mean, Basil, first, thanks for inviting me to this. I mean, look, we're BT, we're here to connect for good, just as you said, and the digital divide is real, and actually it's everywhere. So, in most scenarios, you have this view that there's super urban, super rural. Actually, there's a whole spectrum in between, where it's hard to get to places, or it's an MDU with access issues, or a plethora of different challenges to connect people to the network. And we have a fiber network. We're 5 million homes passed. We're going to build to 25 million over the next 5 years. We've rolled out 5G. It's in 160 markets, but they're not enough. And 5G in particular, there's a lot of talk about millimeter wave and using 5G as a solution, but at the price points we need to hit in the UK and arguably in Europe, it just doesn't cost in. So looking for something that gives us another, if you like, tool in the tool chain to solve connectivity issues, be it in urban, be it in rural, be it in business parks, be it in multi-dwelling units, where I think the solution that you guys have developed fits in all of those areas, and we're really excited to be looking at it. And our mission is, to keep pushing until we've connected everybody, not just the fortunate few that happen to be in the right zip code.
That's perfect. I really appreciate that. And I think that's very similar, by the way, here in the USA, except, of course, we have a much broader geographical problem, potentially. Nathan, you're perfect for this. Actually, maybe I'll come over here and join you on the panel. What the heck?
Absolutely.
You're perfect for this because you built Wisper from the ground up. You climbed the towers. You started the company from day one. You've built the systems. So that you're a real Wisp from day one kind of guy. So and you've tried every technology out there, right? Maybe you can tell us a little bit about how it fits in where you're going. You're a big CAF 2 winner now.
Right.
So obviously you have an opportunity to grow quite a bit here. Maybe a little background on what you're thinking and how you look at Tarana changing, or what you can do with in your business.
Yeah, so I started Wisper 18 years ago, not even out of my garage, but out of my Honda Accord with a fold-up ladder. And at that time, you had to know what pigtail to buy, what box to buy, what power supply. You put it all together, never used a Pringles can. And you built the radio and went out and installed it on the customer's house. And I've always prided myself and Wisper in testing every bit of equipment out there. But you had to be exponentially better. You couldn't just be a little bit better for me to switch. So we've tested everything, and I found Tarana about two and a half years ago. I was actually here in San Jose meeting with other companies that had new modulation schemes and new promises for everything.
Stories.
Yes, stories. I loved your intro.
Yeah.
But what we found is when we installed them to test them, and then we introduced interference, which is what we all have, it would fall apart. So I started looking. I'm like, who's dealing with interference? Who's the company out here? And I found Tarana. I emailed Rakesh and said, hey, my name is Nathan Stooke from Wisper. I'm the second largest winner in CAF. I won $220 million could we meet? And I'm here in California today. And he emailed me right back. It's amazing how my emails get returned a lot faster now.
Well, with that introduction,
right?
yeah.
You know, and we had an hour-long meeting scheduled, and I think I walked out of there 4 hours later, and I'm like, this is real. This is really, really stuff. So for 2 years, we've been working, just understanding where it is, what's going on, and then we got to install it. And when it lived up, you know, most manufacturers, they tell you what it can do, and then you hope and pray you get 50% of that, and then when you get 50% of that, you're happy. This one, it's like, whoa, wait a minute. You actually said it was going to do that? And you know, some of the numbers you had up there, we're pushing 8 miles non-line of sight at 300 meg. Now, it's not a forest, but it's a whole bunch of trees. 350 meg down by 80 meg up, the testing we did last week with the CBRS version. Just mind-blowing, amazing what it's able to do, and it is the real thing. And we jumped on it as fast as we could because it changes the whole directory or direction of where we're going and how we're going to be able to grow our company.
So maybe jumping back to Calvin real quick on a follow-up on Africa. Are there opportunities in the other parts of Africa as well, or let's say in even more developing economies than South Africa, where you think this kind of solution works? I've been told by several people who are in the business that, you know, fiber is so cheap in some of these countries, you can just trench wherever you want. Don't worry about it. You know, why would you run wireless? Just throw it in the ground. So, or aerial. What's your view on that, Calvin?
Look, I think there's massive opportunities in Africa specifically. The trenching, way leaves, et cetera, in Africa is very, very difficult. And it's always the last mile opportunity, you know, to a small thing like way leaves, they tend to not exist. You know, no one actually knows where the existing cable infrastructure is, electricity infrastructure, and so on and so forth. So wireless just makes sense from a last mile perspective. And the economics also make sense, you know, to trench in those environments. We've done the business cases, we've looked at it, and it really does make a hell of a lot more sense to do the last mile on a wireless infrastructure. And, you know, ultimately back to Neil's initial comments earlier, we need to connect everybody, you know. Yeah, sure, there are opportunities for fiber, and in most countries, sure. Throughout Africa, there are opportunities for fiber, and we don't dismiss that. However, if we want to connect every single person in that country and make sure that we break that digital divide, we have to look at these kind of technologies. And for us, this is a great technology, and it certainly makes sense. You know, MTN as a group is 21 countries, and this product makes sense in all 21 of those territories ultimately. So we're excited about the product, and you know, the rollout in South Africa was the start and phase one, but I certainly see this going out into the other territories as well.
And I would have to say, Calvin, it was really heartening to see some of the stories we got back from, you were mentioning to me, that several of the customers you're serving in the early deployment literally previously only had a cell phone to use for home broadband. And they're very expensive and they have caps on them. So it's really, it really means you really can't have a home broadband experience. And so this is kind of a bit life-changing for some of the people you're serving, isn't that right?
Totally. I mean, mobile was the only thing that they could do, and as you're saying, most of it was capped. Decent speeds, but you know, capped experience. Now, anybody who's ever tried to use broadband, you need an uncapped solution, or unlimited solution, so that you can actually use the internet for what it was built for. You know, if you're constantly worrying about streaming your Netflix, but you can only watch one Netflix movie tonight because that's your limit. That's a challenge. It's certainly not what it was built for. We need to use the internet for what it was built for, and that's unlimited. So this technology makes a massive difference, and it opens up so many opportunities for the users out there. And ultimately, it's breaking the digital divide. And in Africa specifically, we see it. I mean, the digital divide is massive, and this is certainly a product that will hopefully. Well, it is breaking that digital divide, and we're hoping that we can roll this out quickly so that we can see the difference as soon as possible.
Yeah, we're super excited about the initial deployment's been really great, and we're looking forward to kind of marching through not only South Africa, but also ultimately in some of the other properties which we're engaged with, so I really super appreciate that.
Absolutely.
Hey, Neil, back to you for a second. 3GPP. You guys are big time in that. You build big mobile networks. You have your acquisition EE. You're obviously one of the incumbents. How do you look at this technology vis-a-vis that? I mean, and I'm going to ask the same question of you, Nathan, because I know you've done a little bit of testing here. Give us your thoughts on. I mean, some people would say, hey, well, you guys just take your big 3GP network and just do a variant of it and stick some stuff on houses. What's the big deal?
Yeah, I mean, look, I think a great question, and something, I mean, almost daily, I say, why do we need to do something different? And it comes down to two reasons. The mobile network's great if you're doing mobile stuff. The hint's in the name. If you're kind of just attaching to something and just using it to haul bandwidth, just the way it's designed is just not efficient. And also, and the whole mobile ecosystem is a kind of a collection of different people's IP, all of which is quite expensive. We've built this ecosystem that's very complex, but works everywhere, which is great. If you go to Japan or if I come to the US, your phone still works, but that comes at a cost. And those sort of features you don't need. If you're just hauling data down from point A to point B, 10 kilometers away, you don't need half that functionality. And also, you have a different set of parameters that you're trying to capture in the radio side of the network, and different coverage constraints, different local regulatory constraints. So, you having something that fits the use case more accurately, that you can do at a reasonable amount of scale is clearly a better answer, no matter what the approach. And also, spectrum is not an unlimited resource. I mean, we're very fortunate to some extent in the UK. We're pretty spectrum rich, but even so, we're looking at an unlicensed use of the spectrum in the 3.8 to 4.2 megahertz range to allow us to offer, even more connectivity to consumers, but also businesses as well. So, and then people say, well, go millimeter wave, and the cost to deploy that effectively for the kind of unlimited demand that Calvin talked about is very challenging. And even if you had the money, getting the permits, building the towers, just building one tower in certain parts of the country can cause an avalanche of protesters and folks who love the technology, just don't want the tower in their own backyard.
Yep.
But also recognize that that there's a need for this. So going down, having something where you've got a lot of reach to play with, and still being able to offer what we call an ultra fast service, so a service greater than 100 megabits per second, is hugely valuable. And as an incumbent operator, we have large exchange buildings and towers in most locations that we can just build sectors out of that and enable it. And even in our lab where we've been doing working with trial customers with this solution, we've been able to get customers up and running pretty quickly. And that's the other thing is, the solution needs to be simple, and 3GPP is anything but simple.
I like your first comment about the hints in the name, mobile, but we do have this one issue, which is mobile homes, which is kind of in the middle there. You're not sure what to do, right? We'll have to figure that one out. So one last question, maybe a bit quick, because I want to give the audience a few questions. I think we're running close here for you, Nathan. That has to do with the overbuild scenario that I commented, where I said, hey, we looked at Sacramento. Most WISPs so far have been kind of serving hard to serve customers that are don't have a lot of options. Things are changing now, obviously, with government funding. What are your thoughts about kind of going into a fairly good-sized metro and just saying, hey, here's a new service, and we can offer it ubiquitously in a decent-sized area?
Yeah, my short answer to that is absolutely. Because before with fixed wireless, you kind of mentioned it in your intro, and Neil mentioned it, we couldn't scale. So you crumbled under your own success. Yeah. Oh, look, I added all these customers. Ooh, I don't have enough spectrum now, or I can only do this many customers per base station. What do you have? And now you've flipped the script on that. And now I can say, well, I don't want to forget my rural market, but I'm going to go back into these urban markets, urban, suburban, and pick up. I mean, the ISP industry is ripe for the picking. I mean, have you ever met anybody who likes their ISP? Right? I mean, really. And there's a model
you
in
need
there.
to come to the UK.
Right? Yeah.
Everybody loves us.
Okay. In America, have you? So when you look at that, it makes a huge opportunity where we always shied away from those areas because we were going after the unserved. We were going after when nobody has a choice. You can do it with fixed wireless. But now it opens the market so much for us, and we're super excited. Again, we have several of our towers that are getting to the rural market, but in the process we go past a whole bunch of. And that's why we're offering 400 meg service. Right. And these customers are like, wow, they really don't even care what the technology is. They just care that we can offer it and it works. Right. And we're proving that we can.
Yeah, and they don't want you to turn it off. So we're running a pilot right now. And the first, after a day of running this, the customer that we're piloting with is, you're not going to turn this off, are you?
Yeah.
It's a very sticky product.
Okay, so we got you. That's great. Now we got a customer now. Hey, so listen, guys, I really want to thank you. Let's do we have time for one or two questions, Stephen, or are we? Yeah, good. Okay, good.
Sure do.
Yeah.
You guys appear to have done such a great job that our audience is simply in awe out on.
So
on
we're all the way to belief, huh?
Yeah. All the way.
So we're at belief. We actually don't have any questions online that I haven't answered technically, just to take care of them.
Very good.
But we can certainly open it up to the room, or you guys can keep talking. It's kind of fun.
Yeah, sure. If there are any questions in the room, just throw your hand up, and we'll just go ahead, please.
Just shout it out, and then Basil will repeat it.
How many sites do we have in South Africa right now? Calvin, that one's to you. Cells. How many cells? You mean like cell tower cells? How much infrastructure? How many cells? Did you Tarana cells?
Yeah, we got about 150.
Tarana cells. Go ahead.
Yeah, we got about 150 live at the moment. So, I mean,
go ahead, Calvin.
Yeah, and the great thing about that is that those 150 towers, we aim to hit about 400 by the end of the year. Those 400 towers will match the current fiber footprint of homes passed in South Africa. So it's a ridiculous metric when you look at it. With 400 towers, we basically match the current fiber footprint from homes passed. So it's a fantastic technology.
Yeah.
So my follow-up question will be about intercell interference. So we have seen these isolated cells that work very well with 79 customers. Can you say something about dense deployments with many cells in an area? What do you see? What can you say about intercell interference?
Yeah, so I'll start, and maybe you guys, if any of you want to jump in. First of all, we actually, obviously for us, like you said, the first thing I want to see was a link through some trees. Second thing I want to see was a sector fully populated. The third thing I wanted to see, personally, actually originally, when we talked to these, I want to see multiple cells stepping on each. We have in San Jose here, we put together 2 sectors that are test sectors for us that are crazy overlapped in a way you would never deploy. So they're literally kind of overlapping in a way that's pretty destructive. And the key here is interference cancellation. That's what makes the difference. And it doesn't only help with a single, but it helps with multi-cell as well, because the way we do interference cancellation, we can do very deep nulls in the proper directions and literally deal with either asynchronous or other cell tower interference. I know we've seen that in the field. We have extensive reports on this, by the way. If anybody's interested in them, we'd love to share those with you, because that's we actually, I think after this session, we're going to have a pretty deep dive on some of this, and we can walk you through the details. But that's a very, very key question you're asking, because, like you said, oftentimes things start to break when you start to have sectors overlapping.
Yeah, I ditto what he said, but we've seen it in the real world with our real customers, and it is living up to everything you guys planned for it to do, because it really does work, and channel reuse of one is a real thing.
Yeah, I mean, that's the other point, is we're doing channel reuse of one across, so basically any kind of, the spectral efficiency you get out of the system when you put it all together, not just n equals 1 for reuse, but also 6 spatial planes, and the strength we get out of each spatial plane in terms of recombination of signals. That's where you get the tonnage. That's where you get the ability to deliver the service.
When we were pushing the LTE providers, we were testing, they say they could do channel reuse of 1, and then when you go to implement it, they then tell you all the drawbacks. Well, I mean, you can, but this is what you're going to have to plan for, and this is what you're going to have to do. We didn't have those here because of your underlying secret sauce technology allows you to do that, and it's been working great.
Any other questions?
We do have one question that came in from the audience, which is, what do you do about hills, and especially co-channel interference and so forth as it relates to that?
Yeah, it's a bulldozer. We got to get the hill out of the way. Well, listen, again, I'll start. I mean, obviously, if it's completely obstructed, you're not going to go through the hill, right? On the other hand, if it's in the Fresnel zone and it's catching a piece of it, we take it. In one of the things that Sergio had shared, and I think you're going to talk about a bit more, is multipath is generally hell for wireless technologies, and the reason it's hell is because the reflections and the refractions arrive at slightly different times, so the signals, when they're recombined, start to be destructive. And the further you are from the transmitter, the more destructive it gets. Now, if you can turn multipath into your friend, he calls it heaven, the way you have to do that is you have to listen in those various directions in a very precise way, and there's a lot to doing that. And then you have to, in the digital domain, do all the shifts in time and phase and all that to make them constructive. That's huge processing, but it has huge benefits. So that's kind of how we solve the problem of, you mentioned a hill, refracting around a hill, refracting around trees. One of the other things that's really super interesting is the time-based, the frequency with which we're recalculating the picture. So reforming the beams. We're doing that much faster than any other wireless technology. Therefore, if a bus goes by and reflections change or a tree moves, we can track that, and we can continue to use the reflections in a productive way. So it's really, like I mentioned in that one slide, this is from the ground up. This is first principle engineering. This is not, hey, let's just take this stuff and do it again. This is say, hey, what would we need to do if we wanted to do X? And in this particular case, the technology, Moore's Law, silicon, processing has gotten to that point where we can do that cost effectively. 10 years ago, you couldn't have done this, right? You couldn't have built these algorithms and got them done in a cheap package that sits on a house. Well, cheap. A well-priced package that sits on a house. I got to be careful, right? Good.
So there was kind of a follow-on to that. You talked about Moore's Law helping you out, but Moore's Law helps out everybody. So what was it specifically that helped the Tarana team kind of crack the code on interference cancellation?
Well, it's true that Moore's observation, which I think that people have now recognized as an observation that's slowing with time, so let's call it, even Gordon Moore has said it's Moore's observation, has gotten, everybody gets to, the whole industry gets to take advantage of that. The key is starting with a fresh piece of paper and looking at the art of the possible and having the deep knowledge of the algorithms to know how would you, if you wanted to, codify these algorithms into something that's cost effective. That is the art. And that is an art, by the way. That's not science. That's an art. You got it because it's that complex to try to think through, okay, if I wanted to do this particular calculation, what's the way I would have to do it? We're not talking about standard processors here. We're talking about very tuned silicon that's implementing these algorithms. And the only way you do that is to be a bit of an artist that understands the palette, and the palette changes. You know, you have your canvas changes, your tools change, and then you get to create. So I think this is, to your point, or the questioner's point, this happens in all industries. Everybody at the vanguard of every area, there's a team that's looking at what's possible and recreating, and that's kind of what happened here. I think we've lost Neil. Neil, you still there?
Yeah, I'm here. Sorry.
Okay.
Sorry.
Yeah, no worries at all. No worries at all. Absolutely good.
Yeah, I mean, look, I think absolutely spot on. We're trying to stretch where we can go and how we get there, and in effect, that means we have to try different things, and as said earlier, the whole interference thing is literally the battle that we fight, and you'd be amazed, even at Christmas we notice more interference when people turn on Christmas lights, and that can take out coverage. It's our biggest issue, and we are trying to challenge we're looking at alternatives, and as an incumbent, that's hard because we're trying to, cookie cutter everything, Basil, and so coming up with a solution like this where you've got to think very differently about how you deploy it. But the win is that you're able to connect lots of customers at really great bandwidth rates, in a way that's cost competitive, and offsets the challenge of building fiber to some places where it's just never going to be economically workable. And the mobile network, even if you build to these areas, you're never going to get the coverage or the reach that you need that this sort of solution can provide.
Perfect. Well, with that said, I think if there's, I think we're a bit out of time here. If I got it right, are we good, or where are we? Got 2 or 3 minutes? Okay, we'll take one more question and then we'll bring us to do a summary.
Yeah, just shout it up.
Yeah, this is more from Facebook. Very interesting. And how many simultaneous users do you see per sector? Is it 128 simultaneous?
How many users per sector?
Simultaneous.
Simultaneous. Yeah. Well, okay. I'm going to say what the system does, and then I would ask that some of our panelists kind of comment on the real world what they're seeing out there. The system can support up to 256. It actually can go beyond 256. Right now, it supports up to 256 subscribers per. And they can all. We actually did a really interesting test where, and this is always part of the challenge here is scheduling the resources or the scheduler. And of course, that's a big area of focus here at the company. So we actually ran a test where we did speed tests with 70 simultaneous subscribers, all blasting as fast as they could to show that we would kind of maintain the performance of these nodes. So the answer is everyone can be simultaneously using the service. Obviously, there's a limit, as there is in any medium. And all of these mediums, whether it's fiber or coax is a tree, fiber is GPON, there's a sharing going on because there is no scenario where everybody is using it full bore. That's obviously, if that were the case, well, the networking industry would be the richest industry in the world because we'd have to build so much networking gear, it wouldn't be funny. The truth is that actually what you're seeing on average is generally a pretty light usage with some variations. But when the bandwidth's needed, it's key here is when a customer wants to use it, it's got to be there. It's got to burst when he needs it or she needs it. Yep. Any comments, guys, on sectors and number of customers?
Yeah, I mean, listen, we haven't managed to push it very far. I mean, the biggest sector we've got so far is with Popular with only 50 customers. But I mean, it works absolutely fine, and the customers are getting the full speeds that they subscribe to. So, yeah, I mean, it's going to be interesting to see it, but we're certainly seeing that. I fully believe that we can do the 256 without a challenge.
Yeah.
One more? Yeah, go ahead, Stephen.
Yeah, one more from the audience, or the audience online, sorry. How do you guys counter the consumer perception that's fed by the fiber industry and the fiber operators that fiber is the only thing?
Yeah, I don't know, maybe one month free trial, because after they try it, they're not going to care, right? I mean, it is something that our industry has to battle with, especially here in the U.S., that it's fiber, you need it. They don't. And if we can get them installed, then they typically don't really shift away. So it's something that we're struggling with. One comment I'd like to make, kind of go back to the hills and everything. I think for everybody who's evaluating Tarana, who's evaluating your wireless network, you need to fundamentally change the way you think about your network design. So the way we used to think about it was the best non-line of sight solution was line of sight. So how many towers do I need to put in? How many repeaters do I need to have, or small cells do I need to have? And you start building out these areas. Our town that we're in has 4,000 houses, lots of trees. We have 3 main towers and 4 repeaters, and we need like another 16 small cells to get 80% coverage in town. That was how we did it, a 3-month process, 6-month build, whatever you end up coming up with, because that's the way we've done wireless in the past. Or when you're successful, to your point where you had 10 towers, because I'm successful, I can't put that many access points. In our town now, I put up 1 Tarana tower in the middle of town, which I happen to have a water tower, fiber fed. Boom, 95% of the entire town is covered, plus all the areas in the rural market. I'm counting my success by town now, not by tower, not by where we're doing it. So you really need to understand and change your philosophy, because when you start looking at your CapEx and then you look at your OpEx, it isn't the same. You cannot compare apples to apples. You have to understand what is my true OpEx, what is my true CapEx, and then when you put it into the Tarana model, you're like, oh, I like this. I can do this a lot faster. I can do different things, or I'm not going to crumble under my own success. So I would really encourage everybody to kind of throw out the window the way you've built wireless in the past, at least fixed wireless, and then come back in with a fresh set of eyes as to how you can do it when you have a tool that works, when you have a tool that does non-line of sight, when you have a tool that scales, because they've solved all of our biggest problems, and other people solve them one at a time, and it just doesn't work. They've solved them all together in one package. Thank you very much. And that allows us to do what we can do now, but you have to change your mind. So that's what I would leave everybody with, is change your thinking on how you build your network.
I think we have to let that be the final word. Go ahead, Neil. Neil, do you want to jump in? Or
I was just going to look. Basil talked about the whole grief process. I don't know how many people in my team are like super. When they first saw this, they're like, Neil, you've got another one of these crazy ideas. I tell you what, when it gets plugged in and up and running, and you see how well it actually works, it's almost amusing to watch the gotcha moment of those folks that when they see this platform up and running. And I 100% agree. If you come at it like you've done any other wireless network build, you'll miss the opportunity. You don't need to. You can think very differently. And actually, the thing I love about this platform is it allows you to think from the customer in rather than the cell site out. Mm-hmm. Yeah. And that is the difference that this platform gives you.
Well, that's another great final word. But hey, with these kind of final words, I want to keep going. Why make it? Why would we stop? Yeah. Oh boy.
You said it was snake oil.
Snake oil. Yeah. Thank you, everybody. We really appreciate it. All those folks online, I think we're going to now sign off for the main webinar. We appreciate you joining us here in California, wherever you are, and thank you very much.